Hello sir, good morning. Myself Ranoji Patil. Today I am presenting my ISE activity in solid mechanics. My topic is biaxial stress state in thin-walled cylindrical fuel tanks. The thin-walled cylindrical fuel tanks are such in a, in a abdomen like in aircrafts, like it adjusted inside the wing. So, introduction. Fuel tanks in aircraft are often thin-walled cylindrical structures because cylindrical structures are suitable to store fuel inside the wings of aircraft. Subjected to internal pressure due to stored fuel. The thin wall are subjected to internal pressure because of the stored fuel inside the cylindrical tanks. Analysis of stress is crucial for safety, efficiency, and lightweight design. To analyze stress for crucial safety from fuel hazard and efficiency of aircraft is also maintained and lightweight design because every aircraft having is lightweight structures. So thin wall assumption thickness much smaller than rating. So project overview, thin wall assumption. Then we have the definition of thin wall thickness because if we take like this cylindrical fuel tank, so we have to find wall thickness. Stress distribution across thickness is considered uniform. So simplify stress analysis to member theory. So we are assuming that thin wall cylindricals are like such these cylinders or this type. This is vertical and this is horizontal. So this is covered by side and the main portion is like cylindrical. So types of stresses. Types of stress in cylindrical stress tanks like hoop stress. It is a circumferential because the stress is applied according to the circumference of the cylindrical act around the circumference. So it is called as hoop stress. And longitudinal, it is axial stress. It's along the cylindrical length because cylindrical having its some length and because of that the stress is distributed. So together form a biaxial stress state. So analysis, hoop stress. After derivation, we find internal pressure. Like hoop stress is stress sigma H is equal to P dot P into 2R into dx upon 2T dx. So we find rho H sigma H is equal to PR divided by T for hoop and for hoop stress, and R is a radius of cylinder, P is applied pressure, and T is thickness. For longitudinal stress derivation, axial stress due to internal pressure is like sigma E is equal to P pi r square divided by 2 r 2 pi r t, in which r is radius, t is thickness, and p is applied pressure. So then from these two equations we find this is equation for hoop stress and this is for longitudinal, and for applying both stresses, then we got finally biaxial stress. So result, biaxial state. Cylindrical tank under pressure has two principal states represented on Moore's circle on stress element, and then we find the ratio like sigma E raised to sigma H. Then we have to find 2 raised to 1. So application of this aircraft fuel tanks, wing and fuselage integrated tanks. So cylindrical thin wall tanks are often used inside the fuselage or wing. Stress analysis ensure tank can store large amount of aviation fuel without expensive weight because of every aircraft is a lightweight and it wants only lightweight. So prevents can leakage of under pressurization during high altitude because in high altitude the inside pressure is very high, and because of that there is no leakage we have to take. And rocket and spacecraft propellant tanks, for that the propellant like liquid oxygen and liquid hydrogen because H2O2 fuel is can stored in the thin wall cylindrical tank. Tanks operated under the very high internal pressure because when we increase the altitude, then inside pressure of the tank is much bigger and it goes increasing rapidly. So biaxial stage analysis crucial to avoid catastrophic failure. These are some tanks. In aircraft, the tanks are located like in the wing part, and it is now it is looks like different, but it is only um, cylindrical tanks, thin walled cylindrical tanks. This side and this side. This is another one cylindrical tank usually in a rocket. So, conclusion. Biaxial space nature. Thin-walled cylindrical fuel tanks are subjected to the two principal stresses, like a hoop stress, like a circumferential and longitudinal stress. It is an axial stress. With the hoop stress being twice the longitudinal stress, making it making it the dominant factor to design. So design and safety importance. Accurate stress analysis ensure the tank can withstand internal fuel pressure without bursting or deforming. Because as we say, as we know that theory, when increase the altitude, internal pressure goes on increasing. So because of that, bursting and deforming is happening. So we have to avoid that while still keeping the structure lightweight. And after finding this factor, we have to keep structure lightweight. Partial application. Understanding biaxial state helps engineer prevent the structural failure such as cracking, fainting, and creep in fuel tank. Because internal pressure is much high, then these failures are happening. So ensuring long-term reliability. Thank you.